So for the component and their function, we have 7 components. First of all is evaporator coil. The function is a heat exchanger coil. Evaporator coil help heat move from the refrigerant to the material that has to be cooled. The second one is refrigerant. The material that transforms from a liquid to a vapor in the heat exchanger evaporator is known as the refrigerant. It is essential to the cooling process and travel through the evaporation coil. And the third is expansion device or steady flow device. The expansion device controls the flow of a high pressure liquid refrigerant into an evaporator coil. It often takes a shape of an expansion valve. The fourth is a section line. The section line joins the compressor and evaporator's outlet. It enables the compressor to receive the low pressure vaporized refrigerant again for the subsequent cycle. And the fifth is a distributor. A distributor can be employed in a multi-circuit evaporator to divide the refrigerant flow evenly among the several circuits inside the evaporator coil. And the next is fins and fans. Fins expand the evaporator coil surface area in the cooler evaporator, and fans help move air across the coil. And the last one is a temperature and pressure sensor. For monitoring the control purpose, temperature and pressure sensor may be mounted at different locations inside the operator system. For the operation condition and parameter specific, we have 5 operator conditions. The first one is temperature setting. For the fresh food compartment, typically set between 1 degree Celsius to 4.4 degrees Celsius. And for the freezer compartment, maintain at a negative 17.8 Celsius to 23.3 Celsius. The second one is control setting. For the thermostat used to control and maintain the interior temperature of the freezer and refrigerator section. For the defrost control the evaporator coils automate or manual defrost cycle to avoid ice accumulation. For the third is energy efficiency. Energy star rating show the refrigerator energy efficiency with high rate model that use less energy. And the fourth is defrost cycles. For the automatic defrost, the necessity for manual defrosting is reduced by the automatic defrost cycle include many modern refrigerators. For the manual defrost, certain type might need to be manually defrost on occasion. And the last one is air circulation. For the internal fan on certain refrigerator guarantee uniform cooling air circulation, minimizing temperature fluctuation.
Hi, I'm Kelvin. Today I'm going to present about the analysis of the steady flow device performance. Changes in parameter 1, fluid flow rate, and parameter 2, which is temperature gradient, significantly influence the stability and efficiency of heat exchangers. The contact time and heat transfer efficiency has higher fluid flow rate, result in reduced contact time with heat exchanger surfaces. Besides, it has shorter residence time, may lead to decreased heat transfer efficiency and increased pressure drop. As for the effect on the SSFD, higher fluid flow rates can lower the overall performance of the steady flow device. Second, the inability to sustain state conditions may hinder the device's capacity to transport heat effectively. As for the temperature for parameter 2 impact, which is the first one, is the temperature differential. It can increase the temperature gradient, indicates a greater temperature differential between hot and cold fluids. Other than that, the heat transfer equation suggests an impact on the rate of heat transfer. For the impact of its SSFD, it has a greater temperature gradient can enhance the steady flow device's performance by encouraging faster heat transfer rates. Other than that, higher gradients depending on design and material qualities may lead to issues like thermal stresses or inefficiency. Now, I'll be present about the comparison of parameter changes. Before that, I'd like to introduce about it. Analyzing the trade-off between temperature gradient and fluid flow rate is crucial for optimizing the steady flow device and overall system performance. For the first one, it is temperature gradient versus fluid flow rate. It has greater temperature gradient improves heat transmission. The higher fluid flow rate has a detrimental effect on steady flow. Other than that, trade-off and balance. A balance between temperature gradient and fluid flow rate is crucial. Besides, achieving optimal steady flow device function requires considering the unique needs and constraints of the system. As for the effect of device on overall functionality, we can see the first one, it is impact system. The steady flow device significantly impacts the overall system. Other than that, heat transmission efficiency and system stability are directly influenced by the device's ability to maintain steady state condition. Besides that, importance of steady flow device. The first one is well-designed constant flow mechanism ensures effective thermal performance. Other than that, operating within predetermined parameters enhance heat exchanger efficiency and stability.
Now I'm going to present about the discussion. When the mass flow rate of the air increases, the mass flow rate of the R134A also increases. The increment is to maintain the efficiency of heat transfer and achieve the steady state conditions. For the second parameters, when the temperature of air leaving the system decreases, the work done for the R134A also decreases. A drop in air temperature may mean that less effort is needed to chill the air. The strength is it absorbing heat from the surrounding to enable the phase change and maintaining the low temperature for food long-lasting keeping and food preservation. The weakness is the force formations. The weakness is the force formations occurs in the evaporators in high humidity conditions. It will cause the heat transfer efficiency to reduce. Inefficiency heat exchange will give the impact of the environment and increase the energy exhaustions. For the case study, the lesson learned is the significance of good design is emphasized by the successful applications of contained flow device. The necessary for efficient defrosting techniques to handle force accumulations on evaporator surface is highlighted by real-world situations. Mechanics and for defrosting that are prompt and energy efficient supports ongoing operations. Hence, the potential improvements or modifications is the advanced defrosting techniques. Next, the overall efficiency of constant flow device can be increased by reduced energy loss via the use of better insulating materials and procedures. Last but not least, the environment considerations also very important to reduce the climate change by lowering the energy consumptions to the surrounding areas. In conclusion, the thermodynamics laws, such as the zero laws, first law, and second laws, are very important in the study flow device. The thermodynamics principles explains how heat exchange functions. The first law states that the energy cannot be created or destroyed, but it can be converted from one form to another form. The second law states that the energy have the quality and quantity. The zero law explain about the two bodies are in equipment statements when they meet with the third body. The heat exchangers always conserve thermal energy. The evaporators in the refrigerators works important to balance the flow rates so that the food can be long-lasting when kept in the refrigerators at a low temperature. The steady flow device is the parameters such as the pressure and volumes remains constant over the time. The entire choosing materials carefully, sizing components precisely, and taking pressure limits into account. The study emphasizes that in order to reduce the amount of force that forms on evaporator surface, using cutting-edge defrosting technology can help to ensure the efficiencies and energy extraction should be a primary focus in the design and operations of steady flow device. The future rich directions of the steady flow device are advanced defrosting technologies, innovative designs on the evaporators, research into the refrigerators of smart technology such as the touchscreens or the sensor, and also voice control. Next is to minimize the environment's effects by lowering the energy consumptions to reduce the impacts on the environment such as the climate change and the greenhouse effect. So that's all is from our groups. Thank you.